righty, and I have cut Sterling Allen loose. All righty. Let's see here. We got 74 people in the chat room. About I'm a little surprised here. We only got about 160 anonymous cowards, but that's okay. I guess it is what it is. I am going to play the feature bumper now. You're going to have to be patient with me for a couple minutes. It's going to take at least a couple minutes to get all the Skyping all squared away. But if you'll stand by for that couple minutes while I play out the feature bumper and a little slide show, I'll see if I can't wrestle Mr. Eric Dollard to the ground to get him in here to discuss his earthquake detection system with us. Stand by. Alrighty, appreciate the audience being patient while I connected all had to push all the right buttons, get everybody connected up. I do have Eric Dollard available at this time. Eric, you there, man?
I'm here.
All right. Now, Eric's audio is not quite as good as I would like. I tried tweaking it up with the mixer panel as best I could. We are on an analog phone. It's as good as we can get, guys, so, you can bitch and complain all you want, but hey, it is what it is, and we're rolling with it. On the other line, coming in via Skype, I've got Zero Fossil Fuel, regular in the chat room. I'm going to embarrass him here and say that he is an Eric Dollard fanboy who was biting at my ankles to get an opportunity to say hi to Eric while we were doing this interview. So, that is the featured event for the evening. At this time, Eric, I know that in general, you're here to promote this latest project that you're working on. To me, to keep it simple, I think of it in terms of earthquake detection, but I know you got a fancier name for it. What are you calling this gizmo?
Well, it's actually a rather broad electrostatic technology, and the earthquake feature is just one small part of it.
Oh, so this thing will do more than tell me if they're fracking in my backyard, huh?
Yeah, I mean, the earthquake thing is kind of a sensitive issue because that's a suppressed subject. So mainly the primary suppressors are the USGS, and if they find out anybody's doing this stuff, they destroy them. So we're dealing with some very sensitive ground here.
I see. Now, why would that surprise me? I would think that USGS, seeing as how they're kind of charged with, this particular, thing, that they'd probably be gung-ho and they would probably be a source of revenue to develop and produce
actually,
it.
I've discovered in the half century of combating this in my life that it's actually the opposite. So they actually are the biggest suppressors of this type of knowledge because they have the money to do it. They don't know what to do with the money they have, and they can't make anything that works, so that becomes a complication for them.
Well, that's interesting. I would, matter of fact, one of the things I was going to suggest was that maybe USGS would be somebody we need to approach to get.
Oh no! It's the kiss of death. Believe me.
They say that.
Oh no, that's why I hide. No, it's serious business. The suppression in this electrostatic technology and the rest of it is really serious business. I mean, I have my wounds on it. I'll tell you. But that's not a topic for discussion here. But a lot of people are familiar with that.
Well, so if we were to avoid mention of earthquake detection, what else might this thing be sold to do?
The way to approach the thing is that all of this actually came about from a Navy submarine communications project and Radio Corporation of America and Ernst Alexanderson and Carl Steinmetz in General Electric.
And this is the ultra low frequency stuff that they were using to communicate with.
Well, it's not ultra low frequency. This is called extremely low frequency to very low frequency. So the seismic thing, as the project was established, this goes back 2 generations. George Van Tassel and someone that's lesser known, a man by the name of Walter J. DeRoche. And a large installation was built in Landers, California. And once the process was discovered and the seismic thing was developed, it was mainly to be part of the Southern California Gas Company, Los Angeles Department of Water and Power, and Emergency Services of County of San Bernardino. It was kind of a secret project, and you can't just, get out on the air and tell there's going to be a giant earthquake and cause a catastrophe. There's a lot of complications in this technology that people don't acknowledge. It's a really tight situation.
Well, that's interesting. Well, then, okay. I mean, how are we going to make use of it then? How is it going to become of any value to anybody if you can't tell them?
The plan was if you knew how many natural gas and petroleum pipelines are underneath the ground, and if you knew the violent forces that are potentially available in the power lines and all the rest of it, and all that stuff gets turned into a mix, in Los Angeles an earthquake, the fires will burn for 250 years. So the idea was is you can't just tell everybody to evacuate. Obviously, even to the smallest-minded person, that's not feasible. It's already gridlock as we speak. So the only thing you can do is have the people in charge of the fuel that will supply the fire have their hands on the off button ready to go ahead of time. That was the only sensible way to deal with it. The fire departments and the so-called authorities and all of them are so wedded in politicism and the rest of the stuff is they have to be kind of kept at bay. But if you can find an organization or a jurisdiction that wants to cooperate, there's a lot of possibilities there. But believe me, I mean, for me to try to convey this stuff to someone that doesn't know how to operate in this world, I mean, I'm really kind of at a loss, but I think you can kind of understand what I'm saying.
Well, you know, maybe I could get you to give me some kind of a feel for what this thing looks like. I mean, mechanically, what are the constituent parts? What does it sound? What does it look like? If I was to see this thing from 50,000 feet, how would I recognize it?
Well, the system just looks like an old-style glass insulator long-distance telephone line.
I see. Now,
but
is this
the details
just
in the loading networks that connect the sections of the line and the contact to the interior of the Earth through the ground system.
Now, is this just a single run, or does it kind of go out like wagon wheel spokes, where you got to have multiple runs feeding a central location, or how?
No, it's a linear network. It should consist of like 30 or 40 miles of long-distance open-wire telephone line, which is no longer available. That's all been destroyed. But it will work down to smaller levels. The system at Landers, the underground antenna was 800 feet long, and the overground antenna was 600 feet long, and it worked quite well there, other than the massive power line interference that the power companies are transmitting in the ground right. That made it difficult, but that's okay. It did work at that level. We established a range of underground reception of 200 miles, which is about all you need. You don't want to go much farther than that because otherwise you're going to be hearing signals in places you're not protecting.
Okay, now is it the wire?
But the thing that makes it work is actually inside a box that connects the sections of wire together.
Now, is this wire that we're using? Now, you say this is old style wire, so is this like 25 pair copper or bigger than that?
Well, it's the overground. It's called J carrier. It's approximately 10 gauge. It's called 104 mil. It has a steel core with a copper sheath around it, so you can find this stuff everywhere out in the desert because it has absolutely no scrap value. You can find miles and miles and miles of this stuff, just like you can find untold miles of the old 8-gauge galvanized iron telegraph wire from the railroads. It was just all left behind. So I don't think anyone's old enough anymore to remember that when you used to drive along the road, there used to be the big poles that carried the power lines, and then there were shorter poles that carried these incredible like racks of glass insulators with lots of wires in between. And that type of structure is suitable for the two antenna networks that are used. One's called the Beveridge antenna, and one's called the Alexanderson antenna.
Okay, now are you sending a signal down this antenna and getting a return, or is this totally passive?
No, it's totally passive.
Okay, so this wire just sits there, and it connects up to a black box, and it's the magic black box that does the trick.
Now, the thing is the structure that is carried on the utility poles in the proper terminology is called an analog computer. And it consists of a zigzag of wires and networks that connect the zigzags of wires together that have coils and capacitors and active devices in them that manipulate the interactions between the zigzags of the wires, and then each one of these networks has a fifth terminal that connects to the Earth. So what it kind of looks like is a fish skeleton with the top part cut off and the under part stuck in the ground. electrically. Now, and this connects to a terminal facility that separates the frequencies and analyzes the frequencies. The interior of the Earth is just a massive quantity of electricity. There's frequencies and signals coming out all the time. They're so strong that actually, if you really go out into the deep desert, you can, and the conditions are right, you can hear these sounds coming out of the rocks because of the voltage induced on the rocks causes the rocks to change shape, particularly if there's any quartz present.
Yeah, that would be the piezoelectric effect, or kind of the reverse thereof.
Yeah, so, well, the piezoelectric is bidirectional. So if you apply electrostatic stress to quartz, it changes its shape. If you change the shape of quartz, it creates a piezoelectric stress, electrostatic stress. Now, as far as the origination of these signals go, there is no theoretical description of how these frequencies can come about.
Okay, now these frequencies are RF? You're picking them up as RF frequencies?
Well, radio frequency, it's hard to say, audio frequency, radio frequency, they tend into the audio frequency range, particularly right at the onset of the event. The frequencies become fully audio and they become fully sinusoidal. But it starts off as a complex spectrum. So actually, initially, in the stable sense, when nothing is disturbed, it creates interference to Navy submarine communications.
I see. So, you know, when
it goes beyond that.
And when they spool out that real long antenna behind the submarine, it's hard to call home, huh?
Well, it just adds to more of the transmission impairment. Okay. There's crackling and carrying on, and it just creates a complication, and that's the way that is. Now, there's a convergence between the overground interference and underground interference that occurs at about 18 kilocycles. 18 to about 22. And a little beyond that, it starts to lead to the overground. A little under that, it leads to the underground. So the Navy has gravitated on a band where the interferences tend to cancel out. Now, when a seismic condition begins, all of a sudden the interference starts to go lower in frequency and become less impulsive and more coherent.
All right, now explain that to me. If I was looking at it on a graph.
In other words, if you have an impulsive signal is like, you know, raindrops hitting the roof or crackling noises, and a coherent signal is like a musical chord.
I see. So you're monitoring what's going on, and you're hearing something that sounds like a bowl of Rice Krispies. It's going snap, crackle, and pop, and that's just normal background noise. But then all of a sudden you start to get kind of a steady rhythm to the.
Well, it becomes more coherent. So a pop, when you look at a pop on an oscilloscope, is just kind of a jerk to one side. But when it starts to become more coherent, the jerk starts to go through kind of like an instability. It starts to swing back and forth. And then that swinging back and forth will last longer and longer, and the wavelength will become longer and longer, and the frequency will become lower and lower until the thing finally becomes like a steady tone. And that is the point of disaster.
I see. Now, when you see that steady tone, is it too late to do anything, or is that?
Well, no. The whole build-up process gives you quite an advanced warning, and this stuff is very dynamic. It's a very complicated. I shouldn't say complicated, but a very little understood process of the interaction between the overground field and the underground field, and how. What it is that makes hurricanes and earthquakes make signals in the ionosphere that are one specific pattern, where volcanoes and tornadoes will make another signal that has a different type of pattern. The Earth is a very intense electrodynamic system, very complicated.
Right. Now, is this the type of thing that requires a human being to monitor and interpret, or are there patterns that are clear enough that you might be able to audit?
Right? The networks can pick it right out. You don't really. It's good to have a human to observe the developmental process and see if there's any kind of extraneous signals coming in. But I've designed networks that extract all this stuff out, put it right on a chart recorder, and when it reaches a certain level, it closes the relay and sounds alarm.
Okay, I was thinking of some kind of small embedded computer. Could it be trained to recognize?
Oh, you don't need computers for this stuff. This is a totally analog system. You don't need all that complexity.
Well, for most of us, computers are fairly simple, and they, for a task like this,
they're not simple. Computers involve millions or billions of semiconductor devices and complicated interactions and all that, where you could do the same thing with 10 coils and 10 capacitors.
Okay, so you'll have to excuse me. I cut my teeth with DEC, and I immediately think, oh well, shoot, let's just automate that. Let's not waste a human being on it.
Well, you don't need to, but you can do that with coils and capacitors and diodes and relays. The digital process actually is inimical to the whole receiving process.
You probably wouldn't need anything more than the processing power of an Arduino.
Well, there's a person, Steve McGreevy, that sells these little electrostatic receivers, and you can hear this stuff yourself in favorable locations. Because they're close to the earth and they pick up the overground-underground interaction, and if your batteries are good and you're in a quiet spot, the way that thing will be screaming and carrying on, and the way the dog will respond to it, you'll intuitively know that it's something strange.
Eric, what is the longest
high-tech thing? Simple.
Eric, what is the longest period that it takes? Or that you can give in terms of a warning of an actual event? How long before the actual event can you actually predict the occurrence of the event with your system?
Well, the last episode that I witnessed at Landers was the famous Japan earthquake.
Right.
So my chart recorders started to act funny. So what happened was the overground recorder, which senses the ionosphere, had picked up a massive electrostatic disturbance. I didn't have two stations to direct at it to tell where it was coming from, but the intensity was such that I figured that something bad might have happened in San Francisco, but I had no local alarms or telluric things. There's no reason, very cautious about calling anybody or being a Chicken Little. I just observed the thing. 1 hour later, Japan...
You saw an anomaly, but you didn't know where exactly to call it.
What's that now?
You saw an anomaly, but you weren't exactly sure what it was or that it would be a cause for alarm at that point.
Well, no, but it had to be paid attention to. So that's
right.
What the installation at Landers was about. Was the observatory of all these phenomena. So the overground recorder pins.
So that was the earliest.
Look at the spectrum analyzer. Let me finish. I'll describe the exact process of how this came about. So, I passed the spectrum analyzer into the overground. The massive noise storm. Either hurricane or earthquake. There was no hurricanes because I had all the satellite maps and all the weather diagrams and everything from NMC and Bolinas printed out, and so that was not the source of electrical activity. So it was an observational point. 1 hour later, they got the first shock, the precursor earthquake that was the big one. Made about maybe a 60 or 70% indication on my seismograph, which is extremely sensitive, and the Earth shook for 4 or 5 hours until it damped completely out like it normally does. But the overground chart recorder kept staying way up to the top, and then 2 days later, then the major alarm went off of giant Earth movement. The seismograph pinned out, and we had the main event, and then the overground recorder returned to normal.
Okay, so the short answer to my question then is the maximum amount of warning that you could give of the event was about 2 days.
48 hours. The Landers earthquake, which conveniently enough was built right on top of the thing when it was just field telephone wire and ground rods, gave an 18-hour advanced warning. At the Bolinas station, we received a 12-hour advanced warning of the Northridge earthquake at Landers. That also gave an 18-hour advanced warning. It seems to be that about 18 hours, because the Japan earthquake was not within the range of my telluric underground reception. That's why I didn't call anybody or say anything. But that earthquake created so much RF that it lit up the ionosphere and came down in Landers. And then the Landers earthquake, is I knew a TV repairman in town that told me that the amount of electricity that was flowing in the ground must have been massive because it permanently magnetized the color television picture tubes, and he sent them back to the manufacturer to find out why they couldn't be demagnetized, and they were puzzled how such a force of magnetism could be put on that iron shadow mask in that tube to permanently magnetize it forever. That's 5 or 10 million amps flowing in the ground.
That brings up a good question that comes to mind. I mean, so apparently you have some problems with directionality. You can't really tell range or direction. You know something's going to happen.
You have to have more than one station.
I see. So it'd be like triangulating. You get a...
Right, so the next station, once Landers was fully engineered and developed and established, then its companion station was supposed to go in Lone Pine, California in Owens Valley. And then that would give a stereo projection on the Southern California block of the San Andreas Fault.
Okay, see, that makes a little bit more sense to me. I was trying to, well, gee, all this is going to do is going to be like a novelty. Okay, so I know something's going to happen, but I don't really know
but
where.
You have to remember, a good radio operator does not need a lot of equipment or whatever, and can determine from the observation of his instruments that even without a directional station, can get an idea kind of what's going on. That's where you're talking about your computer.
The reason for my question about how much lead time you had before the actual event occurred was, I'm wondering, in terms of usefulness, if you had this information and you knew an event was going to occur, what do you do with the information? You can notify the population of the area where you think the event will occur that it's going to occur, but you may as well say to them, well, forget about trying to get out because you're gonna bottleneck yourselves trying to get out. But
you can't do that. The only thing is you have to ready. The emergency services people have to be readied. The main thing is to start to cut off the fuel that's going to feed the fire. The power company and the gas company are the first people that need to be notified of this. Then, whenever the political government realities, which are not friendly to anything, whatever they want to do or how they want to react, they have to figure on their own how they're going to do this. You just don't, all of a sudden, get on the air and tell everybody you're all going to die in 24 hours. I mean, it doesn't make any sense.
Yeah, the face-eating aliens. The face-eating aliens just landed. Kiss your ass goodbye. Yeah, Orson Welles tried that.
There's ways to deal with it. The radio stations can start to get really, heavy duty on. Oh, it's time, for earthquake awareness or whatever. The Amber Alert 9/11 police fantasy signs can start flashing on the freeway saying, slow down, accident ahead. I mean, that's not my job.
Yeah, we think immediately that you need to inform poor Joe Schmuck, because his house is going to collapse on him. But you stop and you think about it, and the realities are, my God, if you did, you probably would instill a bloody panic, and you could hurt more people in the panic than would actually be injured by the event, particularly if, like you say,
it would turn into a compound disaster.
Yeah, I mean, like you say, if you could at least shut off the gas and shut off the electric, shut off the water. A lot of people would start pissing and moaning because they don't have any electric, they don't have any gas, they don't have any water. But, once the earthquake came, they would say, oh, it's a damn good thing we shut off the gas and shut off the electric and shut off the water.
I saw questions.
You don't necessarily shut it off in advance. The electrical system discharges pretty quickly. The gas system takes a very long time to discharge. That's the complication. But if the utility companies have advance warning, see, this thing is It's more like weather forecasting because you never know what's going to pop up because you're dealing with nature. So hurricanes and earthquakes make same frequencies, just like tornadoes and volcanoes make certain frequencies, and new things happen that the humans haven't experienced before. Right now we're going through a massive change in the way that the sun cycles and emits its energy that hasn't occurred for 500 years. And these things all play part. So it's not like, a low oil pressure light. It's a very difficult situation, and that's part of the reason, I would imagine, why it's suppressed.
How does your technology compare to, your system compare to current earthquake detection technologies in terms of how much lead time you can get for warning?
There is no comparison. It's like comparing an elephant to an amoeba.
Well, I understand, but give me an idea of time frame with what is currently at least.
The current system, which is semi-ludicrous and doesn't really do much of anything, is the idea is that electromagnetic waves propagate faster than earthquake waves. So, if you have a network that picks up a disturbance at some location, the microwave links that will carry that to a distant location will give you advanced warning because it will only take microseconds for the signal, where it might take between seconds and a minute for the earthquake to reach you. That's not really a lot of advanced warning.
Are you familiar with some of? Are you familiar with some of the work the Russians have been doing with what they refer to as torsion fields? I know they've been experimenting for about the last 30 years with something they call torsion fields, and they've got some mechanism that they say is real cool for detecting earthquakes. To be honest with you, I've read a few papers on it, but it was way over my head. I just wondered if you might have read the same papers and had a better understanding of what the Russians were talking about than what I do.
Well, not really, because I'm approaching this whole thing, from the RCA Navy submarine communications standpoint. I only know what exists in the technology, radio technology, electrical engineering. I mean, the Russians have come up with a lot of stuff. Maybe they found something advanced. It sounds very complicated, and my stuff just involves basic radio technology that was created by Nikola Tesla and Marconi and Alexanderson and those kind of people. Basic stuff. It worked a number of times. It's already responded to several major earthquakes. And it's very simple and easy to implement. It uses antiquated telephone and radio technology and the components thereof.
Now, you've kind of hinted that there might be more to this than just earthquakes. I mean, how much of weather in general might this be able to predict better than what we've got right now? I mean, can you really predict a hurricane or a tornado? I mean, do they give precursors before we start seeing the storm
exactly
clouds?
It's all the same, but they all predict on the same level. I've been doing this stuff for a long time. Once I learned the basic principles from RCA and then applied them at my work at Sonoma State University, it's all this stuff is very simple, but the socio-political realities of the Al Gore science fascist establishment and Einstein is fine and all the rest of the stuff just smashes it all under the ground because it's too simple. They hate it because it's too simple. These government laboratories pass billions and billions of dollars, yet I've been told by Josh Reynolds, which was one of my first financial supporters, a very wealthy man, Reynolds Tobacco and Aluminum, that he was amazed how much I did when I was on USDA food stamps that no one else was able to achieve with billions of dollars, including his money that he squandered on all the disinformers.
Well, I can certainly see the motive that the USGS would want to suppress anything that you brought out because you make them look really bad. But
they've gone even farther. This is an interesting story because this is kind of the world I operate in, and it can give you an advantage. Is all these agencies are you can't get two lizards to share the whole together. So What it is ham radio people have known about a lot of this stuff for a long time, but they can't harness it, mainly because it burns out their equipment. And they don't know enough about it, and they're really not that much interested anymore. But at any rate, it was National Oceanographic and Atmospheric Administration, which has a massive sensing network and the communication structure to support it, decided, well, what the hell, let's take these simple little devices like this thing that Steve McGreevy sells, that anybody can, he'll build you one for $100, and you can, from the right place, you can sense this stuff, at least start to get an idea. It picks up other things, but you can start. Let's put one of these at every one of our major sensing sites so we can see what it does. Just let's see what it does. It's an experiment. It's cheap, it's simple. We already have this massive communications network. This is plug these little things in. Well, the USGS sued NOAA that it was not their jurisdiction to be dealing with this and had it all pulled out.
As if they had a say in that.
Marvelous.
Yeah.
Now,
well, what does that mean?
Wow.
A stupid.
Go
ahead.
Hold on a second, if I may. So you have the USGS who is opposing your bringing out these technologies, but in the video that you just released that was filmed by Aaron Murakami, you seem to indicate that there's also some support from the government that you're getting. That seems to be contradictory. Where's the support coming from?
No, you have to remember what I told you in the beginning is there's multiple government agencies. So NOAA got slapped around by USGS, but there's other government agencies. I really don't want to get into that. The area I'm in now is rather famous for some of its experiments and activities. Quite famous. There's massive disinformational stories and fantasies of space aliens and all this stuff. There's a lot of different avenues. And one agency doesn't necessarily go along with another agency, but some agencies have more power than other agencies. It's a very difficult and dangerous situation, and I've been dancing this for a long time in the military-industrial complex, and I'm actually considering I've come out quite well. Yeah. And now there's a time for a turnaround, and it wants to happen. None of this stuff's supposed to be talked about. I mean, this is the problem right now. You can't go out and talk about restricted information on the air to get funding. But I'm trying. It's like a bake sale for the NSA. You understand what I'm saying? It's a really difficult situation.
Now, a stupid question I've got, and okay, you can slap me around if you want to, but I'm trying to get a better understanding of this. Now you're talking about a long stretch of wire that goes out for about a mile. Is there any chance that so that it didn't take up so much real estate, you might be able to wrap this thing in a large coil and not? I'm thinking about the facility. Okay, say I'm a facilities manager.
It won't work like that.
Okay, so the only way this thing's going to work is if I got a long stretch that goes out straight for a mile.
Yeah, it's a situation that involves the dimension of space.
I got you. Okay, so I need a linear run above ground and a linear run below ground. Is there some correlation between the length that you have found as a sweet spot, where if I got a mile above ground, I need 3/4 of a mile underground? Is there some kind of a sweet spot there?
I haven't had the ability to make those determinations.
I see. But the one
we're talking about, you have to remember, I've done all this with just me and my car.
Stuff to do on limited resources there, Derry. Take it from somebody who knows.
And the welfare department usually pays for it on top of it. It makes the economy pretty tight.
Let's talk a little bit about that. And that's a good segue. So let's do some promoting for some money here. Now I do understand that part of your reason for wanting to come on tonight was that you have an Indiegogo campaign where you are trying to raise some money. And one thing about me, I am a good, solid capitalist. I like a free market capitalist system, and I like to see people vote with their dollars. So just in case there's somebody out there who's watching this, somebody who's listening to this broadcast, just in case there's somebody that says, you know, this son of a bitch got a pretty good idea. I think I'm going to throw my beer money at him this week. How would somebody go about helping to bring this thing together? How give us some idea of how they can help make this happen.
You mean on a financial or money?
Well, yeah. I mean,
basis?
you do have a campaign going, and I understand you're pretty close to your goal, but you still got a stretch to go. Give us some idea how you're doing on your campaign and how somebody could participate.
Well, the important thing is an individual put up the money for the bond. I don't know who that is, but needless to say, there's very high level of banks involved in that. We're beyond that point. We have to buy telephone wire, equipment, and all that. That's what the other block of money was for. It's only reaching that asymptotically, so I think we're going to fall short. But once the bond's established and everything, all the papers have been signed and everything else, and there's a bit of operating capital to try to put this system together, the main thing is we have to put a seismograph in here for the town. That's the start. A basic standard seismograph, but it will have this telluric thing added on top of it. And once we do that, then we're expecting, that the governmental support end will climb to reach that. I have my own, my own expenses of trying to operate and all that, but which is independently covered. But the whole idea was to get this money to establish this thing here, make a demonstration of it to the proper authorities or whatever you want to call them, and then it wants to go, and once we make our proof, then we take it from there. I can't say, we need this or that. I have multiple research programs going on.
So this is a means to an end for you.
Yeah, this is a specific public utilities project. This is not really the best place in the world to situate such a station because it's relatively immune to earthquake disasters. But the next step is once this gets quantified and re-engineerable, like at Landers, which was lost right at the completion. Everything vanished. 30 years of work, 2 generations, down the drain, instant like that, just vanished. So now I got to start all over again. I'm not 19 years old anymore. I'm 62 years old. And if we can prove it, that we're not talking and we can make this stuff happen, and there's a lot of anxious reception to this, and this is a very special neighborhood here with regard to this, then I think the massive quantities of funding or whatever would kind of be immaterial. It'll all fall together. But then, I have other things like the cosmic induction generator, the telluric transmission, the AC research with, energy synthesis. I mean, I could be another Edison. I could burn up $50 million and still be, counting my nickels in the supermarket.
All right, for those out there who would be interested in participating financially, there is an Indiegogo campaign right now that I understand is accessible at ericpdollard.com/Indiegogo. And Indiegogo, by the way, is INDIEGOGO. If you've got a couple bucks that is not otherwise committed, and you think this might be a worthy cause to chip in for, please consider navigating to that site and toss a couple bucks in the hat. Maybe you can help move this thing forward a little bit. Now, on this setup right now, where you're physically located right now, you've already staked out some poles and some wire, and you've apparently gotten access to that right-of-way. You've secured some sort of a bond which gives you access to that right-of-way so that you can make use of resources that are already there, right?
Right. That saves lots of work. I don't want to have to dig holes for 54 telephone poles, carry them there, and put them up. That would be a
pain in the ass unless you had one of those,
It's tough. It'd take me about a year.
It might take me at least a weekend. I don't know, maybe 2. Yeah. What about the underground component to this? Now, is that something that's already in place, or do you have?
No, well, that becomes a difficulty because of the nature of the soil here, and there's no vegetation that can service the ground rods. So the spines that go into the ground on this backbone network it's going to be a little complicated. The network impedance will have to be raised to accommodate for it, and that will introduce some other problems. But there's a couple of other facilities, too. So a lot of this stuff is abandoned on government land, and it has to be dealt with. We do have this is a rather secret project, but I can say that we have 25,000 feet of 11-pair 19-gauge toll cable with H-loading spacing, as we have terminals at 6,000 feet to do some rather fantastic underground, this is a direct burial cable, some rather fantastic underground radio wave research.
Okay, so now you're not talking about having to go out there with a ditch witch and dig a ditch for this thing. You've got...
no. This stuff was all put in by Bell Telephone years ago, and now it's government property.
Okay.
There are roughly...
now, is this one of these midnight jobs where you got to do this late at night while nobody's looking, or is this...
Oh, no. This is all, these are all sanctioned projects, so there's no sneaking around.
All righty, so
this is, I can't get into the details now because we're talking about a sensitive situation here and interactions between government. I mean, this is.
Yeah, last thing I want to do is throw cold water on it, but obviously, I'm trying to get this. I'm trying to build this picture in my mind of what this thing's going to look like. Now, I've got a pretty good idea.
There's several locations. This is a massive. Perimeter around what's known as the national security area, so it's kind of an edge. I mean, there's lots of facilities abandoned out in these places. It's mind-boggling. I would say that there are probably 25,000 miles of abandoned, buried telephone facilities existent in the United States that are completely forgotten.
There's probably, I know there's some unused copper running down my street. Since they put the fiber in.
You have a L carrier coaxial trunk line that spans the United States in about 4 or 5 routes, and it's all been cut off at the surface and abandoned. So you have 4 coaxial cable systems that go from the Pacific to the Atlantic in the ground, in existence, that are completely abandoned. How do you like that for a chunk of wine?
And you've got
what a ham radio operator could do with that.
Well, they don't know what to do with it anymore because they're too busy yakking on their little walkie-talkies. There is no more ham radio, just like there's no more engineers. It's all dead.
Well, there's some out there that still tinker.
Oh, there's always someone. That's for sure.
Yeah, there's a little bit of tinker in all of us. We are coming up on 50 minutes here, and I want to make sure that you get an opportunity uninterrupted to give a summary of just one thing I'm kind of hoping I'm going to get out of you. I've got an idea now. I've got a picture in my head of what the receiving antenna, I guess it's okay to call this an antenna.
Well, it's not really antenna, but that's the thing that people are accustomed to. It's an analog computer.
Yeah, but what does the black box gizmo that ties into the graphing machine, what does that look like? I mean, is this something that's
what it is? It's a can that's filled with little coils and capacitors.
Oh, how do you discriminate against these signals? Now you've got all this clutter in the background.
Well, the thing is, if you take a coil and you take a capacitor and you hook them in parallel, and they have some reasonable level of interaction. In other words, if the coil is a 2,000-pound substation transformer or 20,000-pound substation transformer, the capacitor is a 5-ounce, little thing wound with wax paper, aluminum foil, you're not going to get the best interactions. But in general, if you take two matched, one coil, one capacitor, and you connect them in parallel, they respond only to one frequency.
So what you're thinking of is a bunch of those looking at different frequencies, and then you got like a klaxon that goes on?
Well, what you do is then if you take a system of those, then they respond to a system of frequencies.
I see, and you've got a pretty good idea, based on your previous research, what are the sweet spots as far as what frequencies to be looking for. So
Exactly.
I see. So what you're gonna do is you're gonna tune up some detectors that are looking for those specific frequencies.
Exactly. What they're called is called discriminators.
Okay. So I think I've got an idea there.
The discriminator does is pull that particular harmonic waveform out and reject the others. Navigation, well, and most of the navigation signals are gone, but the Navy submarine communications, just wax on the system, and it's audible enough that, it irritates dogs. So you have to have a network that gets rid of that. And then, so the discriminator takes the filtered remains of what you're after, and then it goes to the detector. And then the detector provides a force that either drives a speaker or moves a pen on a chart recorder or closes a relay and rings an alarm bell.
Gotcha. And of course, the alarm bell assumes that you're going to have a human operator who can pick up the phone and call whoever's paying his salary and say, "Hey, boss, we got a klaxon going off here."
Right.
Now, I assume that the human could indeed be taken out of the loop. We could get an auto dialer to auto dial the phone and have a recorded message. Like, "Hey, boss, we got a klaxon going off." So that is a possibility. It is possible to automate this system, is the point I'm trying to get to.
Yeah, it can bring it to a level where, it actuates alarm, and then, at Landers, I stared at the A-scan radar oscilloscope on, the seismograph for 4 or 5 hours at a time. And ultimately, to really do this right, it needs to be done like the old, Cold War days with the Air Force, where there's guys that sit in darkened room and they stare at oscilloscope screens as long as that can be done without them going into hallucinations. I think it's like 4-hour shifts to really get the full picture of what's going on. But nevertheless, there's a certain frequency that when it reaches a certain level, that it will close a relay and set the thing off.
All righty, Zero. We're getting ready to wrap up here. Did you have a couple of items you wanted to bring up with Eric before I let him give his summary?
Can you hear me all right?
Yeah, I hear you just fine.
Okay, because your video froze here on my end, and you've been sitting there motionless with your cup of coffee for about 10 minutes now, so I just wanted to make sure this is still working. I want to try and stay on topic. Some of the questions that I got from the chat room are off topic. Maybe Eric can just answer them briefly. But one of the questions that came in from the chat room, if I would like to get into learning more about this stuff, how do I start? Which books to read? Which experiments actually get into it?
Oh, well, I would say the best thing to do is go back to Jerry Vasilato's Brill Compendium and read all the photocopies he found about the things that the telegraph operators encountered. That was the first discovery of this telluric electricity.
Okay. Good place to start then.
And I've written quite a bit of material on the subject, but otherwise, the subject of electricity. But as far as this subject goes, I think probably your best introduction is to the suppressed book that finally got unsuppressed that I wrote, that I call the RCA book, which is called Wireless Giant of the Pacific.
I have that. I read it. It's very good.
So that is the going back in the time machine and being reintroduced to the technology that was lost.
Okay.
There's other people that cover like different aspects of it. One guy that was heavy into this at one time. I don't know where he went. His name is Mike Thoreau. I don't know what he's doing this day and age. There's a radio operator friend of mine, Steve McGreevy, that has been dealing very heavily with the overground stuff. And if you want to hear some sounds that the Earth generates that will blow your mind, he's the guy that's recorded them. Unfortunately, at Landers, we couldn't record a lot of this stuff because we didn't have that set up. And by the time, and earthquakes just don't show up for your amusement or measuring purposes either.
Right.
That's the other complication,
Sure.
You have to wait.
Somebody named David wants to know, how do I detect longitudinal waves?
Well, you have to start by building an antenna structure or a transmission structure that receives them. So this, what we've been talking about is such a structure. The Tesla transformer is such a structure. There's various gas tube arrangements, but I can't just specify how many pounds of copper and how it's supposed to be cut in a simple telephone call.
Okay.
I did produce a video, 2 of them actually, on this subject that
I have those
the
too.
Borderland Sciences, and those are about the best I can offer right now.
Yeah, the delay lines that you demonstrated there were quite interesting, and
well, there's the delay lines and there's the advance lines.
Right.
That's what you're after. It's the delay lines and the advance lines, and the crux of this technology, which is kind of a restricted knowledge right now, is the delay and advance. The Alex Henderson principle is the delay and advance cancel, and you get an instantaneous function.
Mm-hmm. Okay.
I have put out numerous articles and this book and everything that show you how to build the stuff, show you how to build the Alex Henderson antenna. I put out something on the Energetic Forum called the Camp David antenna that shows you how to build all these log periodic networks and all that. But this is kind of like a new level of ham radio, that hasn't been around since the turn of the century, where it's wide open experimentation. And that's what it's going to take.
I think ladder line as an antenna feed radiates longitudinally, and it's why most ham radio operators experience much better signal capture and transmission with ladder line than they do with coaxial lines, because they don't even realize.
That's not the reason.
No?
The reason that open wire transmissions lines work better is because the natural relationship of electromagnetism is 377 ohms. And the open wire transmission lines tend to operate the velocity light. With coax, you're pinching the wave, and it doesn't want to go into confinement. It wants to get out. It doesn't want to go in there, and it distorts the wave. And for receiving, open wire lines are the best way to go. For when you use coax, the wave does not want to go in there. That's not its home. It's like trying to force a coyote into a cage.
That's a good analogy. Have you ever made a caduceus coil?
I got involved with that with the George Van Tassel situation. And they are space-canceling devices to give you strictly a time wave. So you can build a transmission structure in a caduceus form, and you would expect from the number of turns it might operate, let's say, 10 megacycles, but actually it has overcome the velocity function. It will operate at a couple hundred megacycles.
Interesting. Can you confirm that it produces a toroidal magnetic impulses at each end?
Well, that's somebody's idea.
Okay, I figured as much. And last question from a gentleman named Friar Pino in the chat room. He wants to know what your view is of I can't even pronounce the name, Lidskalman's magnetic current.
I don't know. That's one of those things that you hear about, but you can't build anything. A lot of people wrap themselves up in that, but I can only get involved with stuff that, that I can actually build.
Sure. Very good. Well, that's it, Gary. I'm out.
All righty. Eric, we have run darn near an hour, and, I don't want to be greedy with your time. I realize you've got more to your life than just sitting around talking.
Well, I'm fine right now.
Well, if you're willing to go for another 10 minutes,
that's fine. Yeah,
you're okay with it. Well, one of the things I wanted to do at this point is I wanted to give you an opportunity to summarize this project. Now, I've been down into looking at the individual trees. What I'm hoping to get from you is the big picture view. Let's take a look at the forest here. What would this thing look like if it were implemented on a global scale? How many would be needed? Where, maybe suggest where key areas where something like this might be of value. In other words, give us your idea. 10, 20, 30 years from now, how would you like to see such a system implemented?
Well, the receiving span seems to be within the 200, 400-mile range. So there was a German engineer that was interested in this that worked for Siemens. He had recommended, if I was correct, 104 stations around the world.
104 stations. And, I mean, do you purposely want to locate these things very near known fault lines, or is it better to have them a little ways away?
Well, no, they should really be where they belong. I mean, like I said, the structure that's going up here is kind of removed from that, but then on the other end of the deal, you need, and that's what this situation is going to serve, is you need a reference antenna so that you know what the background noise is, if you see what I'm getting at.
Yeah.
So you have a receiving system in an area that's a reference background, and you compare that to a receiving system somewhere else where the signal's starting to pick up. But in general, there should be, I can only think in terms of the San Andreas Fault. I can't extrapolate beyond that. In that situation, I'm looking at 16 stations.
Okay,
the San Andreas Fault is going to blow statistically in 4 years. And statistically, all earthquake activity is increased by 10 decibels. So it used to be a 7th and 8. So starting with that Indonesia thing, we've gone into this cycle of the change in the solar activity is having an influence on the earthquakes. It's not going to keep whacking on the earth and causing stuff to equalize. It's going to allow higher buildup, according to the stress building theory, which makes sense. So in 4 years, there's going to be a big blast in California. Now, statistically, from the zigzag principles, first there's one south, there's one north, and one south, and one north. It looks like it's most probable that will occur in Southern California, but then there's even larger cycles we don't know about, but that's the zone. That's where it needs to concentrate on first.
Well, I assume that's because you have a vested interest in that part of the world. I mean, frankly, a lot of earthquake activity happens out in the ocean. I mean, and a lot of these ocean earthquakes have impacts on coastal areas. I mean, Fukushima is a really good example. I mean, the earthquake that clobbered Fukushima was out in the middle of the ocean. How are we going to detect those?
If I got a signal of that strength in landers from Japan, if there was a similar structure in Japan, it would probably burn out the input transformers. There would be no avoiding that something severe was happening.
Gotcha. Okay.
So the thing is to concentrate on the danger areas. Right now, California is one of the principal ones. So there needs to be a generalized system that studies the mechanical vibrations, the electrical vibrations, to get a picture of the whole thing. The whole idea at Landers was when the next big event happened, all the processes, mechanical and electrical, that led up to it would be fully documented. They were recorded on chart recorders, and from that point on, there would be no doubt what to do to build a system.
Yeah, now, that brings me to a question that I had from a fellow, I think he's from the Netherlands. He writes me a letter and he gives me some background information about, the last few months, people living in the north of the Netherlands have experienced more and more trouble due to earthquakes. Obviously, this guy's being he don't care about the San Andreas fault. He's seeing stuff real close to his home, and he's wondering, okay, how can I get this here? So the bottom line, Eric, is, come on, man, have a heart. I realize San Andreas is close to home, but there's other folks out there.
Well, I can only do so much.
I know.
I mean, I'm going through the tribulations, today of fixing my car. I mean, I can't afford to heat this place. It's like, I wake up, it's 28 degrees in the morning, and, I mean, it's, I can only do so much. Everything that I did has been smashed and destroyed. I mean, the whole thing has rendered me permanently disabled, which is good because I get disability, so, I can afford to eat and do that kind of stuff. I can only do so. I did my thing. I can only do so much.
I understand, and I'm picking on you a little bit because I did get this letter from this fellow in the Netherlands. Ask Eric when he can help us out here in the Netherlands because we're suffering too. Yeah.
Well, the problem is the electrical system, for reasons we're still trying to figure out, is getting totally tweaked to completely jam out telert reception. I don't know what in the hell's going on. So you have to get away from the noise and all the stuff. That's part of the reason for going out, in these deep, government property Netherlands out there in the distant, dead desert where, there's not enough to feed a starving coyote. Not alone make any trouble for you or any interference. I don't know what to suggest. I mean, the standard method for accessing this is the instrument that Steve McGreevy sells. You have to get away from the interference if you want to be married to your device, and hook it to your stereo or whatever. But you have to, if you're not part of nature and you live in this Babylonian quagmire of harmonics and disruption and pollution, well, I mean, you can't hear what's happening over the thunder. I don't know, I don't know what to say. Even if in a big urban area, you could build a giant system like what I'm talking about, be useless because of the interference.
Yeah, I got a fairly persistent question from the live chat room here. A fellow asking about your books. I think his question is two parts. I mean, he's named off a couple of your books, Quadrant Representation of Electricity, and a couple others. I think first part of his question is, are those books still available from ericpdollard.com? And the other part of the question is, if he buys those books, do you get a little kicker in the wallet off of them?
Oh yeah, that's all. I got married to this facility here that that my Social Security and handouts can't afford, and either I lose it and lose the last everything I have, or I need contributions to pay off this hostage situation I'm living in here, rent and all these things that I can't have part of my life.
All right, so bottom line
I'm
is...
kind of in a desperate situation right now.
Yeah, bottom line is...
So all the book sales, basically... The book sales were supposed to go into Project Gregorio, which was going to be our first attempt at a San Andreas fault station. Unfortunately, people not only hijacked my organization, so now that it's lost its security clearance and defamed me on the air and all that, but they got me trapped in a situation here of insurance and rent and all this type of stuff, and I can't handle it. So... all the book sales go in supporting the so-called laboratory, which really is not a laboratory because it was never funded as such, but it's a place where I can work on my car and wash my clothes and sit in my soundproof room so I don't have to listen to the roaring and growling devil trucks outside, so that I can write all these books, which I've been doing in the past 8 months. I've written more in the past 8 months than I have written in my entire life, multiplied by 5.
And the other question is, did you finish the book Four Quadrant Representation of Electricity?
Yeah, that's been done. Now the next book is in the process of coming out, which is a lot more complicated.
Okay, so that one is published and available.
Of that, and I'm actually quite excited, because I didn't know really what to present in this presentation there and all that, and I haven't but I've made some really phenomenal discoveries, and it's got me all lit up. But now I have to change I have to change because I have to make the next presentation here in June. With the detail and the exactness that I always do on the subject we're talking about.
Now, we probably should give a little plug. There is going to be a conference. Where's this next conference in June going to be held?
I don't know. Someone just gives me directions and I drive there.
I got you. Okay.
Somewhere in Washington.
I'll tell you, you're going to get a nasty gram from Murakami over that. Here, I gave you an opportunity to pitch the darn show, and you ain't cooperating, man.
But I don't know what the names are. So you have to help me out with that.
Oh man, I'm going to have to go back and look at Murakami's notes.
Well, I'm not trying to offend anybody, but I don't know.
I know.
You have to remember, I live in a different world. I live outside, okay? So, I'm way past, the main bearing replacement interval on my car. Now I'm up to driving 3,000 miles a month again. I don't know what's going on. You can't buy real parts anymore. I mean, it's all, I'm at war. And I just as soon disappear into my hole in Owens Valley and never come out again, but I'm committed to this. It's somewhere there, Washington or Idaho. I forget the name of it. I know it's Aaron's thing. It relates to the Energetic Forum, but I can't, you have to give me a break.
Is it the same location as last year?
Yeah, I guess. I don't know.
Okay. All right.
I don't know. I just do this stuff. I don't know.
I understand. What can I say?
The thing is,
my fault. I hit you with a ringer.
The beginning of this talk started about three or four days ago, and pouring rain in the Redwoods. It hasn't rained there until I got there, which is a good sign. And I can't buy the right tires for my car anymore. Because everyone's into this, I don't even want to get into the terminology, but like everything else, it's all degenerate. And, so I was stuck for a day, and it was me and the PRC-47 was all that there was in the world, and pouring rain outside, and the new talk got christened. And I'm putting this stuff out a little bit at a time on the Energetic Forum to kind of warm people up for it, but it's a big job.
All righty, here's
its own path. I don't necessarily have control over it. It takes its own path, and I'm trying. I'm still working on the last presentation.
All right, here's the dealio.
I haven't finished that yet.
Here's the
dealio.
dealio.
I just on alternating current. So now, and there's some governmental projects in that, and things that they want me to figure out. So now I'm switching gears and getting back into the very thing we're talking about, but as far as the telluric, longitudinal, the Alexanderson, the Tesla, the non-electromagnetic form of electricity, the living form of electricity.
All right, I'm gonna go ahead and butt in here and give the scoop on the conference. Thank you, Sterling Allen, for sending me a link. Anybody who is interested in this conference coming up, where I guess Eric is going to be a speaker. I mean, they surely will invite you, right, Eric?
Oh, I'm going to be more a speaker. There's going to be lots of demonstrations. There's going to be stuff that people's never even seen before.
All righty. It's referred to as the 2014 Energy and Science and Technology Conference. It's going to be held June 27th through the 29th. And let's see here. I'm trying to find where. I guess you can. Apparently, they're allowing you to buy it with Bitcoins and Litecoins and Tesla coins and all kinds of coins. But come on, man! Whoever did this website didn't make it easy for me to find out where it's going to be. But all right, I'm going to have to direct you folks to energeticforum.com/energyconference2014. That's where the sign up is. And I assume that somewhere on this page is the location, so you can figure out whether or not it's close enough to you to be interested. And if you do pursue that, you too will be able to see Eric Dollard in person giving live demonstrations. How's that sound, Eric? Did I do a good promotion on it?
Yeah, well, we'll see what happens. Hopefully no one will assassinate me. I've become, this is a very serious matter in my life that I have to take consideration, that I've become the John Lennon of electricity.
Well, you know, I mean, I've
And
got
what happened to John Lennon?
I've got an easygoing approach to this. I just make sure that the guys in the black Suburban who park out in front of my house every Thursday night when I'm doing this program, I just make sure they get donuts with pink sprinkles and Kona coffee, and they leave me alone. You know, on Thursday, I take them some damn
donuts. They could actually be your friends protecting you. You know, you don't know. They're in the business of you not knowing.
That's true. They just sit there and
don't underestimate anybody. Nobody really knows what's going on.
This is true. Well, Eric, look, we've been going for an hour and 12 minutes now. Would like you to have the last word, sir. So your summary thoughts.
Well, I don't know. I'm pretty exhausted.
So I managed to wring you out, huh? See, you were ready to go last time.
Well, no, I can keep going, but I can't be put on the spot. I'll go blank.
I understand. Well, it was a hell of a talk. I hope we manage to help sell some books. Hope maybe we get some folks to participate in your Indiegogo campaign. Obviously, those contributions are required to keep the work going. So anybody out there who feels so inclined, it's ericpdollard.com/Indiegogo. Chip in a few bucks, help Eric out. Cross your fingers. Hope maybe we see something. Anytime.
Well, actually, now that you brought it up, I do kind of have a final thought.
Good, because, I always like my guests to have the last word.
It's absolutely fascinating to me how people have picked up on this and how it seems to be transforming their lives. It completely blows me away.
That's it? That's your parting thoughts?
Yeah, it's...
Actually, that was actually very good, Eric. You did a nice job on that.
Well, I don't know. I mean, I enjoy it. I get all these letters, and people feel so positive, and they're learning things, and it's exciting.
Now, tell us the good news. Are you getting anything done besides working on your car?
Well, yeah, I just, finished 2,500 equations, which are working their way out, and it just, carried out this massive integration into the federal government, and it's hard. What can I say?
All right, Eric. Well, on that note, sir, Zero, any parting comments from you before I shut this channel down?
No, I just want to thank Eric for being on the program tonight. I hope that we can help him out with his campaign. I'm really fascinated by his work. I do find it, Eric's a ham guy, and I'm a ham guy, and I find it a little curious that he's expending so much energy in the direction of the seismic detections. It seems to deviate from the main focus of what I would expect him to be working on. And maybe Eric, you can just address that for me. What is it about the seismic activity detection that either fascinates you, or is it simply a means to an end to further some of your other projects?
Well, it's something that needs to be done, and I
agree with that. Right.
That's a simple matter of that. It's something that needs to be done, and I've made it engineerable. People will support it. It's self-sustainable. It's simple and basic. It makes absolute sense.
Okay, fair enough. So, yeah, that's it. It was a great presentation, and I hope to do it again.
Oh, yeah, I enjoy it.
All righty. Well, Eric, I want to thank you very much for being patient with us and giving us your presentation tonight on the Smart Scarecrow Show. I hope you found this reasonably enjoyable and would not object to coming back again sometime. I mean, you're obviously you're something of a draw. We started this show tonight with about 70 in the chat room. We went a little bit long, so the numbers have dropped off to about 55. That's normal when we go much beyond 40 minutes or so. But apparently there are a lot of people out there who enjoy hearing what you have to say. So I thank you very much for the Smart Scarecrow Show for showing up and giving us a presentation tonight.
Okay, well, thank you.
And once again, I want to remind everybody in the chat room that Eric does have a fundraising campaign going. It's ericpdollard.com/Indiegogo. If you can chip in $5, $10, $20, whatever you can afford, I'm sure it would be appreciated. Eric Dollard and Zero Fossil Fuel, thank you both very much. I'm going to go ahead and cut the connection at this time.